This is the first lab of Physics 2211. It is about constant velocity. The experiment needs to observe the motions of an object that is moving at the same speed without changing direction. The experiment will compare the computational model and observation by plotting both the preserved position versus time and observed position versus time on the same graph. The computational model is preserved based on the Newton's second law. The Newton's second law indicates that the final velocity is equal to the initial velocity plus the total forces added on the object divided by the mass of the object times the time interval delta t. The initial velocity is obtained from the video analysis of the object's motion. Assuming velocity is constant, we should have final velocity equals to initial velocity. Let's assume constant velocity v, and we should have the net force equals to 0. The position is then calculated with the position update formula shown on the left. The final position is equal to the initial position plus the average velocity times delta t. The experiment is about a soccer ball. The positive x-axis direction is to the right. I used tracker to get the information about the position of the soccer ball as the function of time. The reference length is equal to the ball's diameter, which is 0.22 meters, and the x-axis positive direction is to the right. The most important thing to analyze is initial velocity. The initial velocity can be calculated using the first recorded data or the last recorded data, which is shown as v1 and v2. Computational model prediction is based on a recursive formula. So, a small error in the initial velocity will lead to a wrong position at the end. To highly accurate the evaluation of the initial velocity is not easy, because the real speed of the object is not constant. By comparing v1 and v2 on the previous page, I found that v2 is more accurate since it is calculated using the initial data and the last recorded data, so that it is exactly the average velocity over the experiment, and the final position is located more accurate. This is the result of the experiment using the velocity calculated by the initial data and the last recorded sample. The red dots line is the observed position versus time, and the blue line comes from the computational model. The result is quite good. The preserved position is underestimated in the middle, but the final velocity but the final positions are extremely close, since the initial velocity has been assigned exactly equal to the average velocity. Other discrepancies may come from the reason that the tracker's sampling rate is 29.89 frames per second. This is the result when the signs of x-axis are flipped. From the graph, we can see the position is increasing in the positive direction. By assuming the positive x-axis direction pointing to the left, the data will flip their signs, and the position and the velocities will be positive. In order to achieve net force equals to 0, there are typically 4 forces added on the ball. Horizontally, the push force from the hand and the friction force from the table are cancelled out. Vertically, the normal force from the table and the weight, which is the gravitational force from the earth, are cancelled out. Thank you for watching.